A few people have requested this video. How do you get a Vise assembly inside of Fusion 360 that resembles what you have out on your CNC mill? And then, how do you put a part inside of the Vise? The step-by-step coming right up. Hi everybody, my name is Lars Christensen and thank you so much for taking the time to watch this video. Like I said, this is a requested video. I really appreciate all your comments and suggestions down in the comment area. I know a lot of people read them and I can assure you that I read them all. Now, this video is going to be a little bit different than previous videos created, mainly because we are going to be moving through some different categories. We're going to be talking about assemblies, we're going to talk about joints, we're going to talk about stock creation, we're going to talk about components within assemblies and so on. And if you have watched any of my previous videos, you know that I can get a little long-winded. So what I'm going to do is I'm going to reference to a couple of previous recorded videos that you will find down in the description area. But one thing that is the most important thing to me in this video is that if you're following along step by step, you should end up with the same result as I have on the screen. Now, if you do have some questions pop up or you get a little confused as we're moving along here, do me one favor and post down in the comment area and I will do everything in my power to get you squared away as fast as possible. So, let's get going. All right, so let's first take a look at the part we're gonna put in the Vise here. Now, I just wanna make this completely clear before we get going that you don't have to put your part in a Vise. You can absolutely program the part in Fusion 360 without putting it into a Vise. If I go in here to the cam side of things, you'll see that I've already applied toolpath. And if I go in here and hit play, you will see that we can absolutely simulate, we can go through here and completely program the part. Now the benefit of actually putting a part in a Vise is a couple of things. One is that of course we can kind of like get an overview over the layout on the machine itself. We can also do collision detection. So as we're seeing here, the end mill going around the part, we can assure that, we are not hitting the jaws on the part. And also this part here is actually going to have a couple of holes that is drilled through it. And anybody who ever tried to drill through a part have probably tried where maybe they hit the parallel or something like that. So that's some of the benefits from being inside of a Vise. But I want to make clear that I don't always put my parts in a Vise. It's really only when it makes sense to do that, because it does take a little bit of extra time. Now with that said, let's get started with point number one. Let's get a CNC table, let's get a Vise, and let's get it put together in assembly so we kind of like have that layout for us to use. I'm going to exit out of the simulation here and let me just open up the data panel. Now, most of the Vises and tables you've seen me use in previous videos, I actually downloaded those right from the vendor's website. But the Fusion team are actually pretty cool. Put some things down in the CAM samples. So if you go out to your data panel here on the left and you scroll all the way down to the bottom, you will see that you have your CAM samples. Now if you double click on that, you will see in here that you have some workholding and you have some machining tables. Now let's first go into the machining tables. I'm going to double click on that and you'll see that there's a few machines in here. Now like I said, my previous videos I have used a Haas table, so I was thinking for this one, let's go ahead here and pull out a Tormach, and I'm going to open up the 1100 size table here. Now you will see on this part here that we already have, the team have already created these assembly joints. Now, if all this joints and joint origins is brand new information to you, you can go down in the description area and you can find the link to the joints video that I created down there. So definitely check that out if you kind of like want to get one step deeper into this. But one thing that I want you to notice here is that this sample file of this table, we can actually not modify this. This is read only because it's up in the CAM samples folders that everybody have access to. So what we're going to do is we're actually going to save it out from the CAM samples folder into our own folder in here. So if you open up down here, I'm in my first project. Now I'm going to create a new project here, and I'm going to call this one Machine Table and Vises. Click OK to that. And now I have that project. Let's find it here. Now there's nothing in it, of course, right now, but if I hit save, this table that we have on the screen behind this screen will be saved in here, okay? So now we have just saved this out and put it inside of that folder. Now let's go back out to the root of the folder here, and let's go into the Workholding. Now you will see there's a lot of things in here, including some of the things I'm using in that assembly joints video that you can find out in the description area, including the toe clamp and the chuck. But what I'm going to do is I'm going to go in and grab an orange vise, and I'm just going to grab a single vise here. So I'm going to double click on that, and then I'm going to do the same thing to this one, because again, this is a read-only file. You can actually see that showing up here. So I'm just going to hit the drop down and go and say save as, and I'm going to save it in that same folder that we just created down here for the machining. Right here, machine table and vise. There you can see the table that we saved before. I'm going to save that, and now that is out there. Okay, with that, I'm going to close down those two files there and go out to that project. So I'm going to go back out to my main line here, and then we should be able to find our machine table vise project we created. And in here, we are finding the table and the vise that we downloaded. Now we're going to have to put them together. So I'm going to start out with the table. So I'm going to open that file up. And then to bring the vise in here, I'm going to right click on it and say insert into current design. And that is going to bring in the vise. Now, of course, you know, if there's any chance of things not coming in correctly, that happens to me too. So here's the vise. Now I'm just going to grab this handle and just move it out of the way a little bit so we can see it here, and hit OK. All right. So now we are ready to put this together. Now again, if you want to get a little bit deeper into all these assemblies and joints, check out that video link below. That will definitely give you a lot of information. And if you're still a little confused, then definitely hit me up down in the comment area below. But to make this to here, I'm going to go up to the joints, and I'm just going to select on where this dowel kind of location hole here is. And then I'm going to select down on this moon down here, or coin, or whatever you want to call it. And that flips around. And don't panic that you only see the bases moving here when I flip it. The other stuff will follow along when I hit OK. So I do that, and now the vise is mounted here. Now again, you could download the toe clamps. You could mate all those in if you want that, but we really don't need it for this table. And again, if you watch that assembly video, you should get all that information. Now, a couple of things I want to show you though. First of all, you can see we kind of like have a joint showing up in the center, so we can hide that. And then you will also see there's the rest of these coins that this Fusion team have placed here. What is really handy if you were going to do T-slots and things like that. I want to hide them, so I'm just going to go in here and go into the joint origin in here. And if I click the top and I hit down Shift, so like this one here, I can hit the V key for visibility, and I can turn them all off like that, just to clean it up. All right, now I'm gonna save this part here, and then you will see that the table over in the left will now update. I'm gonna give it a comment, make that I have it, add advice, and hit OK. Now you'll see that that gets stored over here as an assembly, right? So now the assembly is put together. This is what I would call a master file. What I mean by that is I would leave this assembly alone and then copy this assembly to where my design resides. So don't bring your design file into this vise. And the reason for that is that at some point you're going to have to move the vise, or you're going to have to put another vise on the table and so forth. And if you're messing with this master, it's going to screw everything up. So what I recommend is you call this your master, and you then copy this one to where your design resides. And that's the assembly that you're putting your design into. Let me show you what I mean. But for us to be able to copy it, we have to break the link between this assembly and this vise. So we're just going to right click right here on this part and say break link. Now there's no relation between this vise and this vise. We've just broken the link between the two. And now we can copy this. So I'm just going to hit save one more time. Okay, now I am ready to use this design for our small cab. So we can machine this one, have it in the vise. So what I'm going to do is I'm going to copy from this machine table over to the folder where I have my original part model. So I'm going to do that by right-clicking. Now again, we're in that machine table and vise folder we created. And I'm going to hit copy. And then I'm going to scroll to where that file is residing. So that's a customer file. So I'm going to copy that over to that file right there. Okay. Now I'm going to go to where this file resides. I'm going to go back out here and let's go to that customer file. And now you will see we have the small cab and we have that file that we just brought over. Now let me close out the original design because we're going to use this copy to put this cab into this. Now, but before we get to that, first we got to talk a little bit about stock creation within Fusion 360. So here's a little neat trick inside of Fusion 360. So you get a part like this and you're not really quite sure the size of the stock. And if you are going to put the part inside of a vise like this, you will need to know what size stock you're going to use. So if I go into the setup, I'm going to create a new setup in here. You will see that if I go to the stock and I zero out the stock offset, I'm in relative size box right now. You actually get the measurement of the minimum size stock for this part. Now that is pretty cool. So whenever you need to order stock, you can go in here and you can get what the minimum quantity is. Now since we are going to program this in a vise, we will not use the relative size box because we normally would have a little bit more stock on the part than just the bare minimum, right? So what I like to use is I like to use the fixed size box. Now the relative size box, to me, this is just my opinion, is great if you don't really know what size stock you're going to end up using because it adds, some material on each side. But if you know what size you're going to use, and we are going to determine that now, I would recommend you using fixed size stock because that will show you the actual dimensions of the stock. And, you should always measure with a pair of verniers, your stock before you throw it in the machine. So let's apply this stock. Now, one thing in the fixed size stock here, there is a round up to nearest number. What is kind of cool, I guess, but I like to have mine at 0 and I will add my own rounding of my own stuff. So I'm going to make this one a square block. So I'm going to make it 4 by 4. Okay. Now, the thickness of, so that gives us, if we look at the top here, that gives us plenty of stock around the part. Now, the thickness of this part, it's always critical whenever you're machining, right? So right now, there is a 1/4 inch thick part. So we're going to need to add some material to this. Now, we need something to hold on to put it in our vise. So I'm going to go in here and I'm going to make it 3/4, so 0.75 thick. Now, notice how the software automatically adjusts it from the center, and that's right here, model position. So I'm going to change that because I really don't want it in the center. I want 100,000 on top, and then I want to flip it over and just clean off the back. So I'm going to say offset from top. And then if I put in 100,000, you will see that the stock shifts. So now I have 100,000 here. The part is a quarter, so 250. So that actually gives us 400,000 to hold on to, what should be plenty here. So I'm going to hit OK to this and accept that as the stock. So this is the stock that we are going to be using on this part. Now, I'm going to come back to this because there's something important I got to show you about stock creation. But point here is that it's extremely important that before you put a part inside of the vise, you need to determine what size the stock in real life actually going to be. So let's jump back over to the vise over here that we have. Now, what I'm going to do is I'm going to do just like I did with the vise. I'm going to bring the small cap that we have in there, we're going to bring that into this design, but we're going to keep the link. So if there's ever any design changes to the part, it will update in here. So I'm going to go over here, I'm going to right click on the small cap, and I'm going to say insert into current design. And that's going to bring the part in like this. Now again, the move command gets automatically activated here, but I actually prefer not to use the move command. I still like to use join, but I think it depends. So experiment a little bit with it, and you might find that the move command works better for you. But I'm going to hit OK here, and then I'm going to use the joint command to place this part over to the solid jaw over here. So I'm going to just do like we did before, and then I'm going to use the move command within the joint. So let me show you. So I'm going to go over here and hit the joint, and you always select the part that you need to move. So I'm going to select this part here, and then I'm going to select the top of this jaw right here, and the part's going to move over. Now again, if there's any chance for things to flip around, it happens to me. So I'm going to flip it over here. So now here is the part. Now what I'm going to do now is I'm going to move this part over, right? We're going to move it over here out a distance. Now remember how big the block was? The block was 4 by 4. So you might actually think that 2 inches is the right distance to place this part in the middle. So let's just say we're going to do that for a second. I'm going to hit OK here to place it. And then, by the way, I'm going to move jaw out here a little bit to here. And if I go in to cam and I create a new, now we're inside of the assembly, so I'm going to create a new setup. And because it's an assembly, cam is going to ask us what we need to pick. So we're going to exit out of the 9 bodies and select the part we need to machine, right? And now if I go back into the stock and do what we did before, so we decided that it was a fixed size box, it's 4 by 4, right? Now look what happens to the stock. The stock actually cuts into the solid jaw. That's not really what we planned. Well, here's the thing. Let's go back to our small cap in the part file here so we can talk a little bit about that. So this is important information. When Fusion 360 is creating the stock, it's not taking the part and finding the origin of the part or the center of mass and then creating the box from that. What it does is it creates a boundary box around the part that is tangent to the outside edges. If I go back in the model environment and I open up a sketch on the back side here, and then I'm just going to sketch a box like this. Now, if I make that tangent to the edges, now notice what happens down here at the bottom. The center of the part is where this is, but the tangency is to this edge. Let me show that with a circle. If I go in here, I could actually create a circle that will be tangent to all those. That's the center of the part. But if I create a line to the center, is actually that line right there. So what we see is that this part here is actually 1/8 of an inch, or 125 thousandths, out from the origin of the part. And that's just because the way that Fusion 360 is figuring out the stock. Now, I did this on purpose because many times you have parts that is not completely rectangle or square, so it doesn't trip you up down the road. So let's go back into the model environment here and edit the joint to make it 2.125. Hit OK. And now let's see where our setup leaves us. And now you will see that it is flush with right here. So it's important to understand that it's not the center of the part that is used for the stock. It actually creates a tangent boundary box that encloses the part. All right, I still got a couple of adjustments to do over on this part over here in the Vise. So one thing I haven't done is the height. So let me go back normal to here. We can see that right now the part is flush with that. So let's go back in and edit that joint. And I'm going to move it up. Now I'm going to move it up 350. That will give us that height. So we still have something to hold on to right here. And the part is still sitting up at the Vise. Now, if you do want the movable jaw to sit at the right spot right, to go in and edit the joint in the Vise. So if we're going into the Vise here, and we go into the joint folder, you will see we have this sliding jaw. I can go in and edit that joint. So right now it's actually sliding. Now, of course, everything goes back to default when this happens. Now, if I instead of going slide, send it to rigid, I can actually move it up here and I could add in that 4 inches right there and hit OK. And now I have that 4 inches. All right, so you might have to watch that portion one more time. But essentially what we did was we took that sliding jaw, that sliding joint that the Fusion team had put in there, and we modified it to be a rigid with that 4-inch distance for the stock. So now we have exactly what we needed to resemble what is going to happen out at the machine. Now, the last thing that I would do, because we come this far, is that I would also put a pair of parallels in there, because that's going to be right underneath the part, right? Now, there's different ways you can do this. You could have them stored as files and drag them in and use joints to put them together. Well, my preference is to actually just create a new component and then draw them right in the file, because it's fairly quickly to do. So let me show you how to do that. So I'm going to right-click and say create new components, and the new component automatically gets active. Now, if you are a little confused about components, there's another video down in the description area that will talk about components. So if this all confuses you, you have a couple of videos to watch. Now, I'm going to start a new sketch, and I'm going to do that right on that solid face there. And the way I normally do it is I just sketch a 2-point rectangle, just kind of like in space like this. And then I use relationship to tie this all together. Oops, I just kind of like lost my spot there. So let me go in here and add a couple of relationships. So I'm going to make collinear this edge with this edge, this edge with this edge, and this edge with this edge. And then the last one I'm going to do is a dimension from this edge to the top of the jaw, and that's going to be 2 inches, 200,000, sorry, just like that. Now I can extrude that out. Some parallels have holes in them. I'm just going to make them solid here, drag this out, and my parallel is 1/8 of an inch thick. So there is the one parallel. Now if I go up and make the top active up here, you can kind of see that parallel right there. Now I'm going to mirror that parallel over to the movable jaw. And the way I'm going to do that is I'm going to actually go up to the construction. I'm going to create a mid-plane between the two jaws. I'm going to select that, select the face, not the parallel, but select the jaw, and select the movable jaw, and I get a plane right in the center there. And now I can go over here to the drop down. I can say mirror, and I'm going to change the pattern type from faces to components, because that's actually what this is, and then select that plane to mirror about. Oops, like mirror plane, there we go. And there we have that second parallel. Now I can hide the plane by going over to construction and hide that. And now let's go in and take a look at our cam again and go in and look at this setup. So I'm going to exit out of the model. I'm going to hit the part we want to machine. Now if all this is a little confusing for it, there's a bunch of videos on the channel. Hit it up down in the comments area and make sure that we share all the links you need. Going to fix size, and it was going to be 4x4. I am not going to round up. We're going to make it 3/4, and from the top we're going to make it 100,000s. And you can see now that things don't look good, because I think I made a little bit of a math calculation right there with my parallels that has to be further down. So let's make that change. That's easy enough. We can go back to our model, and we can go into the sketch that's right down here, edit that sketch, and let's make it another 100,000, I think it is, like that. And of course that's going to update the other side over here. So let's go back in and look at our cam. And I get to do it over every time because I don't hit OK. That's my mistake. Maybe that would have been a little bit easier. Oops. 4, 0, 50, and there you have it. Now we have that lined up right there, and we have the part in the vise. Now, what I would recommend if you go this far is to absolutely go into your setup and use fixture. Now, when we select these components that we just created, the solid jaws, the movable jaw, and the parallel, we can now use that for collision detection. So it will show up when we simulate if there is a collision. That's it. I hope that this was helpful. It should definitely have gotten you started on getting that vise into your Fusion 360 design and be able to put the part inside of a vise. Don't forget, put down your comments and questions down in the comment area below. I will definitely take a look at all of them, and I will try to answer as many of them as quick as possible. Now, since this was about CAM within Fusion 360, if you haven't already, go and click the link to go and get your free CNC Handbook. This is a free download, and there's a lot of great information in there that hopefully you can find helpful. So again, I really appreciate you guys who asked me to create this video. I hope it was helpful. And until the next time, have an awesome day.